Hello everyone and welcome back to our videos. Today we are gonna talk about turbine engine operation, instruments and overhaul. Power plant book chapter 4. As a power plant technician, you are expected to operate, maintain and overhaul turbine engine. To perform these tasks, you must be able to distinguish between normal and abnormal engine performance. Operation. An aviation maintenance technician should be familiar with the procedure necessary to operate a gas turbine engine. This includes understanding the engine instrumentation, ground run procedures, and safety items associated with starting and running a turbine aircraft engine. For any aircraft that you are required to run, first be familiar with the location and movement of the engine control. Here we have a control of engine. We have the power lever, propeller speed lever and condition lever. The control or power lever is used for controls the fuel and engine speed. And here we have the propeller speed lever and used to change the propeller blade pitch, and the condition lever used for fuel cut-off. In addition to the engine controls, locate all of the engine instruments. Be sure to read all black cards and other markings on or near instruments. The engine instruments display important engine operating information. Instruments that indicate oil temperature, oil pressure, airspeed, fuel flow, and exhaust gas temperature are common to both turbine and reciprocating engine. However, gas turbine engine include a few unique instruments. These instruments display the engine performance data, including the first one here, the compressor speed. N1 here in this indicator or tachometer, the N1 tachometer indicates the speed of the low pressure compressor, and the N2 indicates the speed of high pressure compressor. In some engines we have N3, and N3 shows the stage number 3 of the compressor. After that we have EPR, engine pressure ratio. The engine pressure ratio indicates the amount of thrust produced in many turbofan powered aircraft and represent the relationship between turbine discharge and compressor inlet. And you will find sometimes EPR or pressure ratio PT7, PT2, and this also EPR indicator. After that we have PT7, or known as turbine discharge pressure, and this instrument displays the total engine internal pressure just aft of the last turbine stage. Torque meter. Torque meter, you can find it in aircraft that use turboprop or turboshaft engine, and this indicator used to indicate the amount of torque being produced to drive a propeller on a turboprop engine or rotor on turboshaft engine. And the last instrument we have is exhaust gas temperature. A critical limiting factor for operating a gas turbine engine is the temperature of the turbine section. The temperature of a turbine section must be monitored to prevent overheating the turbine blades and other exhaust section components. A common way to monitor the temperature of the turbine section is with the EGT, exhaust gas temperature. The exhaust gas temperature gauge on a gas turbine engine is essential for monitoring the temperature of turbine section. Most turbine engine temperature monitoring gauge include limit marking for different operating parameters. Engine parameters on most modern business jet and transport aircraft are displayed electronically on LCD or CRT. The most common method that used is the Acast, and that means engine indicating and crew alerting system. And here we have our Acast. The Acast is divided into two screens. The first screen shows the primary Acast, and the second one shows the secondary Acast. The primary Acast shows the ABR, N1 and EGT. The secondary Acast show N2, N3, fuel flow, engine vibration, oil pressure, oil temperature, and the quantity. During a normal operation and while the aircraft in cruise flighting, if the upper screen has a fault, it will show on the lower screen because the upper screen has the priority of the lower screen.